Welcome to the video, Steam Locomotives in Harz, from mining pump to tourism. We will explore the history, technology, and legacy of these incredible machines. Our journey will take us through the evolution of steam power, from its utilitarian beginnings in mining to its role in modern tourism in the Harz region. What is a steam locomotive? It is a traction vehicle where the energy source is water vapor, generated in a boiler, usually by burning coal. This energy is converted into mechanical motion to drive the wheels. The story begins with the mine pump, a solution to the problem of flooded mines in the 17th and 18th centuries. Thomas Newcomen's practical steam engine, developed in 1712, used steam to drive a piston, which in turn powered the pump. James Watt significantly improved the steam engine with his centrifugal governor. This mechanical device automatically regulated the machine's speed, making steam power safer and more stable for widespread use. George Stephenson, a pioneer of the steam railway, created the rocket in 1829 for the Rainhill trials. The goal was to find the best steam locomotive for regular operation on the Liverpool-Manchester Railway. The rocket introduced key technical innovations, including the multi-tube boiler for a larger heating surface and the steam blast in the chimney for better draft and combustion. These features became standard for subsequent steam locomotives. The rocket achieved a maximum speed of about 45 to 50 kilometers per hour and weighed around 4.3 tons. These were revolutionary achievements in the 1820s. The rocket was the winner of the Rainhill trials and proved that steam transport was safe, efficient, and profitable. It marked the beginning of the era of modern rail transport. Coal formation occurred millions of years ago from plant remains under pressure and heat. This process transformed peat into lignite, then to hard coal. Coal became a key fuel for steam engines and industry. The evolution of mining technology moved from manual surface and underground extraction to using mechanical hammers and steam pumps for dewatering mines. The first mining railways also appeared for transporting coal. Coal processing involved sorting by quality and calorific value, drying, and sometimes primary coking to produce coke. High-quality, high-calorific coal was essential for steam locomotives and industrial machines. Although coal has a lower calorific value compared to oil, it was cheaper and more readily available in the 19th century. This made it the dominant fuel source despite its energetic limitations. Major coal mining centers in the 19th century were concentrated in regions like Great Britain, Germany, the USA, France, and Belgium. These areas fueled the development of steam railways and factory industry. Coal was the ideal fuel for locomotives due to its high calorific value, which produced powerful steam, and its ease of transport and storage. Without coal, locomotives could not have functioned effectively. Steam locomotives enabled fast coal transport from mines to cities and factories. The first railway lines were specifically designed for coal transport. Local mining railways provided an effective link between mines, metallurgical plants, and ports. Steam locomotives accelerated industry and made raw materials more accessible. Steam power provided a stable energy source for factories. Railway lines sped up trade and urbanization, linking coal and steam to drive modern industry. Examples include Lancashire and Manchester in Great Britain and the Rhenish-Ruhr region in Germany. In Harz, local steam locomotives transported coal to sawmills and factories. Steam locomotives were a catalyst for economic change in the 19th century. The Harz region features steep, narrow valleys, posing challenges for railway construction, particularly for sharp turns and limited space. Building tracks and adapting steam locomotives to this mountainous terrain required special technical solutions. Technical adaptations included narrow-gauge locomotives with reinforced boilers and brakes. Special wheels or cog systems improved traction on steep slopes. Safety and stability were ensured when transporting cargo and passengers. These adaptations allowed steam locomotives to operate effectively in mountain conditions. The Harz narrow-gauge railway network spans over 140 kilometers. Steam locomotives have been in use since the 19th century and continue to operate today. They serve both freight and tourist transport. The Harzer Schmalspurbahn is a living museum of steam rail transport. The Harz narrow-gauge railway operates on three main lines: the Harzquerbahn, Selkettlebahn, and Brockenbahn. These lines connect many settlements and tourist sites.